Hi, my name is Lizbeth, and today we're going to be doing standard enthalpy. So standard enthalpy, here's the equation. It looks really intimidating, but in reality, it's not. So here we see that it's the sum of the enthalpies of the products minus the sum of the enthalpies of the reactants. So usually the reactants are on, or always, the reactants are on the left and the products are on the right. So notice it's going to be the products minus the reactants. That's a very important thing to keep in mind because oftentimes we forget and then we get the wrong answer. So these ends just are there to remind you to multiply the enthalpy by the number of moles present. So those coefficients are actually very important. So the best way to explain this is to do an example. So here I have 2H2S plus 3O2 yields water and sulfur dioxide, and we're going to try to find the standard enthalpy for this. So you're probably asking where I'm going to get the standard enthalpies for all of these. Those are given in a chart. So I actually have the chart right in front of me, so that's fortunate. You should have a copy of it. If you're using the Ebbing and Gammon book, it should be in chapter 6. Page 250. It's table 6.2 if you have that book. And if you don't have the Ebbing and Gammon, it should be in that chapter as well. If not, it's in the index. So let's go ahead and I'm just going to write the enthalpies of each one of them that corresponds to them on the bottom, and then we'll do the flipping later on. So I went ahead and looked up the standard enthalpy for H2S gas. So here is where the phase states become very, very, very important. I'm going to use water as an example. So water as a liquid has an enthalpy of 285.6, but as a gas it has an enthalpy of negative 241.8. Those values are different, which means my enthalpy would be wrong if I used the gas enthalpy instead of the liquid enthalpy. So make sure that when you're looking at your chart, you're using the one that corresponds to the correct phase state. I know that's a very common mistake to make. So here for H2S, I found that the enthalpy is negative 20.5. And there's two of them. And that should be in kilojoules per mole. But I'm not going to write the unit because I'm kind of lazy, but you do. You write the unit, all right? So then we have O2. O2 is found, is a diatomic in nature, so I know automatically that's going to be 0. So that's going to be 3 times 0, and that's, again, kilojoules per mole. And then we have the water one, which we just talked about. It has to be the liquid one. So it's going to be 2 times negative 285.8 kilojoules per mole plus, and then we have 2, and sulfur dioxide gas is negative 296.8. All right. So I'm sure you're tempted to just add them and then just subtract, right? But we first have, let's add them, and remember that's products minus reactants. So here I'm going to have negative 41 as a total on this side because that's 0, so I'm not going to include that. And remember, this is the reactant side. And we're going to go to the products. This is going to be negative 571.6 kilojoules per mole, and then we're going to have negative 593.6 kilojoules per mole. So now I'm going to do products minus reactants. So it's actually going to look like this. 571.6 plus negative 593.6. And then we're going to subtract negative 41. So when you do all that math, you're going to get negative 1124.2 kilojoules. And that's actually your answer for the standard enthalpy for your reaction. So let's go ahead and recap. So what we did here is we looked at our equation, we realized that it's products minus reactants, we went ahead and looked at our table and found the enthalpies for each one of our reactants and each one of our products, and we remembered to multiply by the number of moles because that's what the N and the M stand for. So then we went ahead and added all of those, or did all the math, and then did the products minus the reactants, and then we got the standard enthalpy. So that's how you solve for standard enthalpy using a chart.